Hello there once again. This is Hamza. I'm going to take you through mathematics, and today we are going to discuss what we call combinations. And a combination, for example, those of you who have done some advanced level mathematics and attained some advanced level classes here in Uganda, all over the world, you can have a combination of subjects you're doing. For example, you can do biology, chemistry, and mathematics. That is maybe BCM, if you can shortcut the combination. But those are very few. That is one combination with only 3 subjects. Even if you change it to chemistry, biology, mathematics, or you change it to biology, chemistry, mathematics, or you call it MCB, math, chemistry, and biology, you are still dealing with one combination. However much you are changing the arrangements. You can have various arrangements, but with one combination. So a combination is the number of ways, is the number of groups, is the number of groups that can be got from a set of items by taking some at a time, or all of them at a go or at once. So it's defined mathematically by saying n combination R. This is read as n combination R, meaning you are taking from n items, you are picking R at a time. And those R items you're picking at a time, they're going to give you the different groups you can form out of a set of n items. So n combination R is the same as n factorial out of n minus R factorial times R factorial. Sometimes this can be written as C of nr. So, this is the basic definition mathematically for combinations. These combinations can be applied in binomial expansions, as we shall see. They can be applied in binomial distribution, probabilities. And like I've said, it's the way we can group items by grouping all of them at once or some of them at a time. So, for example, some of the examples we can have, for example, 10 in combination 6. It's the same as 10 factorial over 10 minus 6 factorial, 6 factorial. This will give me 10 factorial out of 4 factorial, 6 factorial. And you compute with a calc and you get the answer. We can have another one, which can be, for example, 12 combination 3. 12 combination 3 is the same as 12 factorial divided by 12 minus 3 factorial, 3 factorial. This is the same as 12 times 11 times 10 times 9 factorial over 9 factorial times 3 factorial. If I divide by 9 factorial, I lose that. This is 3 factorial, which is 6. I divide it with this, I get 2. My answer becomes 220. So those ones we can compute off head straight away, we can get the results. Another illustration we can have on this is that we can have 8 combination 2. 8 combination 2 is 8 factorial over 8 minus 2 factorial, 2 factorial, giving me 8 times 7 times 6 factorial over 6 factorial times 2 factorial. So with this regard, we can have simplification of this expression in terms of having 6 factorial divided by 6 factorial. 2 factorial is the same as 2, giving me 4, and the answer gives me 28. Furthermore, we can have combinations. We can combine 2 items. If I combine, for example, I can combine they can give you an expression to simplify or to prove. For example, there is a question here. Prove that n combination R plus n combination R minus 1 is actually n plus 1 combination R. Now, earlier on I discussed factorial notations, and if you look at some of my lessons on my channel, I talked about how to see a smaller term coming from a bigger term. So you have to express the bigger term in terms of the smaller term. Now this is the same as what? This is the same as n factorial over n minus r factorial plus n factorial over n minus r minus 1 factorial r minus 1 factorial. This is coming from the left hand side. Now, when you look at it carefully, this reduces to n factorial out of n minus r factorial plus n factorial all over into n plus 1 minus r factorial into r minus 1 factorial. Now, when you look at what is subtracting off the r in this case, it should be coming from n plus 1 in the numerator. But we don't have n plus 1 actually up there. So, what shall we do? We shall have, this one is coming from, this is n factorial over n minus r factorial. Now this r factorial can be reduced until you have r minus 1, right? And but before that, let me show you this part. This is n plus 1 times n factorial over n plus 1 times n plus 1 minus r factorial r minus 1 factorial. Now, I have introduced a useful one whereby this reduced by that takes me back to that. So here this is coming from n factorial, n plus 1 factorial. So I have this term, which now I'll have to factorize out, because the whole of now this expression gives me n plus 1 combination r. When I also design it here, I'll have n plus 1 n factorial over n plus 1 into n minus r times factorial times r minus 1 factorial. Now I have designed a reduction of this r, which is r factorial, to reduce it to r minus 1, the smaller term, so that we can factorize effectively. So now I have common terms. Common terms are, we have n factorial. Actually, the common term is now n plus 1 factorial. This is plus n plus 1 factorial over n plus 1 into n plus 1 minus r factorial, r minus 1 factorial. So it gives me n plus 1 factorial, because of the both of the numerators, divided by, I can reduce this one. Now, to make this one become part of that, I extract out n minus r and I reduce it by 1. So n minus r minus 1 will give me, no, actually this is smaller than this one. So I reduce this term to this. So into n minus r factorial times r minus 1 factorial into brackets 1 over n plus 1 times r plus 1 over n plus 1. When I reduce this one, I have reduced it by having n plus 1 minus r. So we are left with simplifying this, so the denominator becomes, we have, now I've taken out this, these ones are the same, no? So let's take them out. So we shall have n plus 1 factorial over n plus 1 into n minus r factorial, r minus 1 factorial into 1 over r plus 1 over n plus 1 minus r. So clearly this is so this is giving me what? N plus 1 factorial over n plus 1 into n minus r factorial, r minus 1 factorial. Then we have n plus 1 minus r plus r, all is over r into n plus 1 minus r. I can lose the r, and I'll lose the n plus 1 to this one. Then down here, we shall have r into n plus 1 minus r, which n plus 1 minus r actually is the origin of this one. So this takes me to n plus 1 factorial over n minus r factorial, r minus 1 factorial times r times n plus 1 minus r. Now this is bigger than this one, so it is this one which comes first, followed by this factorial. Then this one also is bigger than this term, so this one comes after this factorial. So it actually looks like n plus 1 factorial over n plus 1 minus r factorial times r factorial, which actually is n plus 1 combination r. Hence, we have proved what the statement was saying. So with such proofs, you'll land on some numbers which will be of that category in terms of combinations. Now, when we go to practical examples of combinations, they can ask you to combine people to form a committee, to combine people to form a football team, to combine teams to get a betting receipt which can win you money. All these are aspects of permutations and combinations. Now, an example. A committee of 5 is to be formed with 12 men, from 12 men and 8 women. A committee of 5, is to be formed from 12 men and 8 women. In how many ways can a committee be chosen so that there are? In how many ways can be chosen so that there are 1, 3 men and 2 women. 2, at least 2 women. 3, at most 4 women. Okay? So here we go. The first one says we are arranging men and women, but combining them into groups, not arranging them in terms of permutations, but we are arranging them or grouping them into groups. That is how we form a committee. A committee is a group of people. Now, we have to group 3 men first and group also 2 women, and then combine them. So to get the men, we can first group how many men? The men are 12. Out of those 12 men, we are grouping only 3. And after grouping the men, group them with the women. So that's why we say and for and calls for multiplication. And 8 women, we are grouping out 2. So that these 2 R's, when added up, they give us the number we want, which is 5. So you can compute that, and when you press the calculator, the answer is 6160. Then for the second case, now the next ones I will not give you the values, you will press your calcs and confirm the solutions. At least 2 women. At least 2 women means you can combine out of the women at least 2 women, and how many men do you need here? You need 3 men. Or, when we say either or, we add. Or, at least means the smallest number and beyond. Or we can have, out of the 8 women, we can choose 3 women, and how many men? And we can have 2 men. Or we can have, out of the 8 women, we can have 4 women, and we can have what? Out of the 12 men, we can have 1. But they say the committee should be of 12, should be formed from men and women. Unless if they say a committee is to be formed from n of them. Meaning, if there is n of them, there is even a possibility of picking all the women and none of them is a man. So you press your calc and you can get the answer. And when you come to case 3, at most 4 women. At most 4 women, it means you cannot exceed 4 women. Yeah? But at most means you can start from no woman and you can have all of them are men. Or you can have 1 woman and you can have how many men? 4 men. Or you can have 2 women and how many men? 3. Or you can have 3 women and 2 men. Or you can have 4 women. And lastly, you can have only 1 man. So those are the number of ways. So we can have that, and then you can compute with the calculator and confirm that answer. You can have another illustration. Example 2. In how many ways can we form a school team from a batch of 15 players if 1, no restrictions, 2, a particular player has to play, 3, a particular player shouldn't play, 1, when a particular player has to play, 2. Okay. So, case 1, we want to combine. How many ways can we form a school team? Which team is this? I forgot to mention it's a football team. And a football team has 11 players. Yeah? So 11 players are going to be selected from a batch of 15. So that's how you see how Liverpool, for example, can select its first squad, saying Mane is on the team, Salah is on the team, Firmino, Alisson Becker, depending on the lineup the coach wants. Of course, he wants a team which will go in there and make him a win. So he's like, okay, this guy should start. This one should not start. Now they are saying without any restriction. So in how many ways can he assemble a team from a batch of 15 players? So he has 15 people to choose from, but combining 11 at a time is the answer, which is 15 factorial over 4 factorial times 11 factorial. Then you press the curve and get the number of ways. Now the number of ways you can combine these teams gives you the different teams you can have. So the total answer you get here is the number of teams you can form of 11 from a batch of 11 or 15. When you come to Roman 2, when a particular player has to play, maybe the team is a national team and there is a son of the president, and the president wants his son to play in the national team. Yeah, if he's playing on that team, then you have to make sure that you do not bother picking him, but he has to already be on the plane which is going for the championship as you select the remaining few. So if a particular player is selected, it means out of the 15 you have, one is already off, so you're now selecting from 14. And out of the 11 you want also, one still is already chosen. So you're no longer choosing 11 players, but now you are choosing 10 players. So you get 14 combination 10. And that is the answer for a particular player being on the team. Then thirdly, lastly, which is the third part says, a particular player should not play. Maybe this person angered the coach, maybe this person is injured, maybe this person is weak and the game is so physical, this person is unfit, and the coach says that person should not play. Or the manager says, I don't want that person on the team. Or the boss, the owner of the team says, I do not want that guy on the team, he refused to sign my contract. You know those conditions, you've heard about them. So in that regard, that player reduces the number in the batch. The batch was 15, now you have 14. Now, if the batch has been reduced to 14, you still need 11 what? Players. So the answer will be 14 combination 11. Why? One player has gone off, who is supposed to be not picked, and now I'll have to pick from the remaining players, and that is the number of ways or teams we can design. So with that, we have discussed what we call combinations. And with these combinations, I have a different number of numbers here. You can go to Packings and Packings, page 294. You can pause your video and take a screenshot and take a look at the numbers. And with that, we shall have, at least to be in position to have covered what we call both permutations and combinations. I'm still Hamza Luwama, taking you on in mathematics. Remember to put on your face mask whenever you're going out, if you have to go out. Remember to sanitize in every public place you go to, even at home when you're back from out there. And stay blessed. Keep reading, keep practicing. Don't forget to reach me out on my YouTube channel, to subscribe to the channel. And also, in case you need my numbers for the WhatsApp groups and discussions, still 0782 855 674, 0702 550 946. For those students who want to contact me through their parents so that we can have an arrangement for classes, please don't hesitate to hit me on those hotlines. Thank you so much. Stay blessed.